Hi everyone, this is Professor Benjamin, and this is part 2 of the introduction lecture. So in part 1, we finished covering what primary and secondary succession is in regarding the environment, and I was showing you this succession chart and what primary and secondary succession mean, where does it occur, the time it takes for the completion of the process, the soil, whether it's absent or it's there and just kind of disturbed, humus, what happens with humus. And when I talk about humus, this is the really organic part of soil. So a lot of times we'll have like what we call inert soil, and then we'll mix a humus matter into it, which is more of the biotic factor. It has a lot more nutrient value to it. Pioneer community is what we mean is if it's pioneer, meaning it was there first, and then what the favorable environment is. So this is a really good kind of chart for you to use. And then right here, we're looking at change, and I tried to address this a little bit earlier. Humans, again, are always hesitant to change, is that we like to know and predictability of things. Without that, we kind of falter a little bit, and that's a big deal. So, but the environment is always changing. There's always new things going on in an environment or adaptations happening, and humans have a really hard time with that. So change, we must not ignore change or interfere with the capacity to change. Avoid changing tempo of the natural change. We must try not to or copy nature, and look for threshold changes. So this is really important in terms of this course. And we'll talk about a lot of this change as we move through the different sessions within this course. This is a really good defying inevitable change. So this is one thing where we don't like change. So we have a lot of people who live on beach communities, especially in New Jersey, right? If you've ever been to the Jersey Shore, Atlantic City, or even North Jersey shores, you are on a beach that probably shouldn't be there. Beaches are meant to move and change. Beaches are what we call barrier islands. They protect the mainland. When you drive down the Parkway or the Atlantic City Expressway, that is actually what you are protecting, rather than the actual communities where the boardwalk is, etc. They are meant to change, but we as humans don't like that. We've built millions of dollars, billions of dollars of property on them, and we continually do beach replenishment projects because we want to keep the beaches exactly how we remember them and how they are. But actually, beach communities are meant to change. They are meant as barrier islands to protect us from hurricanes. Barrier islands, that's why they're called a barrier, because they're meant to protect the mainland from hurricanes or storm surge or anything else. Okay, so what do we consider uncertainty? So of course today we have tons of uncertainty because of what's going on with COVID, with our pandemic that we have going on. Why we have this uncertainty is because of ignorance and complexity of the environment. And this actually, I'm going to talk about this in terms of climate change. So a lot of people still do not believe climate change is happening. Even with the floods that we have had, a lot of times have to do with more pervious surface and impervious surface, meaning we are paving over a lot of areas such as Collegeville and other areas are building up in Conshohocken, and all of that water, when we pave over properties, rushes down into the Schuylkill and then overflows its banks. But receiving 5 and 6 inches of rain in a day is not something we're used to. Having tornadoes rip through Bensalem or South Jersey is not a normal thing. Having an EF3 tornado rip through a town in New Jersey is not normal. And so it's something new for us. And a lot of times we're like, why is this happening? We don't understand. Well, it's happening because of climate change. But because climate change involves so many different factors and it's just not a straight answer, and we can't tell you exactly what's going to happen because of climate change, we tend to say we don't believe in it because we don't understand it. Because it has complexity and because ignorance is bliss, the fact that if we don't know or we don't know enough about something, it's easier to turn a blind eye to it. okay, rather than accepting it. And so this is a big deal. And this is where our uncertainty in terms of environmental issues comes from. A lot of us are just not well versed in what's going on scientifically with climate change, how it happens, how it's related to the way our lifestyles, how we live, etc. It's also very complex, and we have a lot going on in our lives today. So having something that's really complex and, okay, I want to learn about climate change, but it requires me hours and hours and hours to try and unpack something when I am working 2 jobs and I'm trying to go to school and I have kids and all this other stuff. It just becomes a back burner situation because it's super complex. So these are why we kind of turned a blind eye to a lot of times scientific things that are happening, right? Also, we live in an information age where tons of information is coming at us and we need to decipher it. And that becomes a really hard thing. Who's right? Who's wrong? Who's telling me the truth? Who's not? And that becomes mentally exhausting to the point where we shut down. So that is what I'm talking about in terms of that. This is a great image. I love this image because it's like the weather, right? We want to know. Okay, so for example, today, I'm making this video on September 8th, 2021. And today we have advisories coming through that we may be in a tornado zone again. And people are like, what does that mean? We had tornadoes last week. How can we have tornadoes again? Weathermen tell us exactly what's happening. They can't. They can only tell us up to a specific point. We want to know what the weather is going to be in Cancun in 3 weeks. Well, guess what? Weathermen can't, or weather women, can't even tell us what is going to happen 3 days out. I mean, really, any weather that you see that's more than 3 days out is not accurate weather. Because weather people cannot tell you what's happening that far in advance because weather's so dynamic and changing. And only one little shift, right, can change the entire forecast. This, of course, comes around during snow time, right? You can see weather people now call it plowable snow or shovelable snow, which means that it can fall within a specific range because they don't want to give people exact numbers anymore because any little thing can change that. And then what happens is people then have doubt in them. But in reality, ecosystems are so dynamic and environmental science is so dynamic and there's so many moving parts that it's almost impossible to always be 100% accurate. And we need to give weather people that leeway and stop judging them. And I know you're going to say, oh, they get paid tons of money. And okay, well then you become a weather forecaster and see how difficult the job is. So, to remove some of this doubt and ignorance, we use the scientific method a lot. And I think it's really important for that, is that organization helps remove some of that ignorance and complexity. And that's what we call scientific thinking. So the scientific method is super important. It's super important to this class. You're always going to be doing scientific experiments, whether it's a basic scientific experiment, like, hey, my fan won't work. Why will my fan not work? You're actually running a scientific process in your head as you're trying to figure out why something will not work. And I know that's crazy, but you're always running systematic thinking approaches in your life. The ones that we read about in terms of journal studies are, of course, way more complex, but they are always trying to be able to replicate things so that we can take that doubt and ignorance out of systematic processes. Okay, and so why the scientific method is so important is that there's always a testable explanation. It, of course, could go wrong, and a lot of times our best inventions are made from hypotheses that are proven wrong. Some of our best medications come from that, or a medication that we think is being able to treat one thing winds up being, doesn't work out for treating that specific type of cancer or that specific type of ailment, but winds up being something that we use to treat something else. So oh my goodness, is this recording? Are you kidding me? Is this recording? Sorry. Oh no. Okay. let me move this for a second. Okay, we are recording. Thank goodness. Oh my gosh, I just had a panic attack. The 9 minutes I spent recording this went away. Okay, so here's the scientific method. The next one we're going to do is, and this is really important, especially for your scientific method assignment that you have due this week. And don't forget there's a video that accompanies that right under the assignment that I think you should watch before you complete the assignment. But the scientific method has some other parts that are important. So there's an independent variable, which is the one thing you tend to vary in an experiment. You have the dependent variable, which is the living thing that will change when you tend to measure as a quantitative assessment of effect. So what happens is the dependent variable is what will change in terms of what we're doing. We have the independent variable, which is the one thing you intend to vary in the experiment. So one thing you want to change. The constants are the parts of the experiment which do not change. They stay the same, and we always need a constant group because we need to compare the results against the constant group. So when you're doing your scientific method assignment, make sure you think about that, is that your constants are what remain exactly the same. So the soil type, the type of plant you're using, the amount of water it's getting, the amount of sunlight it's getting every day, that has to stay exactly the same. And then your other group, your experimental group, is the group that's receiving all of the change. Okay, and I talk about that here, the control group or the treatment group. Really important parts of a biological experiment. So here is the scientific method, and depending upon where you look, the scientific method is different in a lot of different cases. Sometimes it's 6 steps, sometimes it's 7 steps. It all depends on what you are, where you see the scientific method, but you're really going to ask a question. And notice in the scientific method, there's arrows going in both directions, which means the scientific method requires feedback. So it's always a constant process where questions are being asked and changes can be made all along the way. So you ask a question, you do background research. Maybe the background research answers your question, or maybe it doesn't even come close to answering your question. So you might need to go back and revise your question again. So lots of things. Then you construct a hypothesis, you test your hypothesis, you analyze and draw conclusions. If your hypothesis is true, of course, you report the results, and then replication by others happens. You may ask a new question and then do it again. If you prove your hypothesis incorrect or false, you may then want to try again and then construct a new hypothesis. So you can see this is a really great flow chart on how the scientific method happens. It's a series of steps. Remember, I love the scientific method because in life, we're always taught you can't be wrong, but the scientific method actually encourages, or it doesn't encourage that, but it actually accepts the fact that everything doesn't always go right all the time. And I love that. I love the fact of trying new things, and if it doesn't work, you try again. In life, so much we're told you get one chance, and here it is. But with the scientific method, it gives us that chance to try over again, construct something new, and you never know, something beautiful can come out of it in the end. So the systems thinking part is really important for the environment, for environmental conservation. It's important in any field of science field, very important in any science field, this idea of systematic thinking. Okay, so that ends part 2 of the introduction, and I hope it gives you a little bit more background information.